That's all for lecture 2.1. Let us discuss about projectile motion now. So let us define the following terms. Projectile, an object launched into space without motive power of its own, so it doesn't have its own power to be launched. So projectile is the object itself. Trajectory, the path traveled by the projectile, mostly denoted by the broken lines to show the path traveled by the projectile. Range, the total displacement traveled, that would be the horizontal distance. Range. Height would be the vertical distance. So this will be the formulas we're going to need to solve for the projectile motions, where x the final displacement, x sub 0 is the initial displacement, v is the final velocity, v sub 0 is the initial velocity, y is the final height, y sub 0 is the initial height, acceleration is meter per second squared, t is for time, and g is acceleration due to gravity, which is 9.8 meter per second squared, or 9.81 meter per second squared. So these are the problem solving strategy that may help you in solving the problem. Since it's a projectile motion, we will be dealing with angle, so we'll solve the initial velocity first with this formula. V sub 0 x is equal to V sub 0 cos theta, and in the y it will be sin theta. Number 2, the horizontal and vertical components, usually asked, these horizontal and vertical components of the displacement. This will be the formula for that to solve for the x and y components. Next, number 3, if we're talking about the displacement there, now we are talking about the horizontal and vertical components of the velocity, so don't be confused with the two formulas. If they are asking for the velocity, this will be the formula you're gonna use. If they are asking for the displacement, vertical and horizontal components of the displacement, that will be the formulas on the number 2. Number 4, final position and velocity can be obtained from their components. So make sure that the appropriate signs and consistent unit are used. Remember that gravity may be positive or negative depending on your initial choice. Problem number 6. A plane diving at a constant speed at an angle of 53 degrees with the vertical releases a projectile of an altitude of 730 meters, so the height is 730 meters. The projectile hits the ground 5 seconds after release. First, we are looking for the speed of the plane and how far the projectile traveled horizontally. Letter C, we are looking for the horizontal and vertical of its velocity, so we have our formulas there. So to solve, we need to first write the givens. So our given is theta would be 53.0 degrees. Y, our vertical distance is 730 meters. Our time would be 5 seconds. Our G, our gravity due to acceleration, is 9.8 meters per second squared. So we need to solve that now. On letter A, they're asking for the speed, so we're gonna look for the V sub 0. To solve for V sub 0, with the formula on the past slides, we can use this formula. VO y is equal to sine theta. So when derived, that will be v sub 0 y over sine theta, but we don't have the v sub 0 y. So we can solve that first before getting into the v sub 0. That will be y minus y sub 0 is equal to v o y t minus 1/2 gt squared. So derive the formula. That will be v sub 0 y is equal to y minus y sub 0 plus 1/2 gt squared over t. Substitution. That will be 0 meter minus 730 meter plus 1/2 multiplied by 9.8 meter per second squared. The time would be 5 seconds squared. All over 5 seconds. So VOY would be negative 121.5 meter per second. So we can now solve for the v sub 0. So v sub 0 is equal to v sub 0 y divided by sine theta. That will be negative 121.5 meter per second over sine. Our theta would be 53 minus 90 degrees. That will yield negative 37. So negative 1 to 1.5 meter per second divided by sine negative 37 will be 202 meter per second. That will be the speed of the plane. Next, we will be solving for the x. Since we are asked the how far, so x minus x sub 0 is equal to v sub 0 x. That formula can also be seen at the past slides. 80 squared. So deriving, that will be x transpose x sub 0, which is equal to 0. Zero meter plus v sub 0 is 202 meter per second multiplied by the cos negative 37 degrees multiplied by the time, which is 5 seconds. Acceleration there will be 0, so we didn't solve the latter part. So x is equal to 807 meters. I'm sorry if the camera did not get the 5 seconds. For letter C, we're looking for the horizontal and vertical components of the velocity. So we're gonna find the Vx. So Vx is equal to Vox. So Vx simply equals to 202 meter per second multiplied by cos negative 37 degrees. So Vx is 161 meter per second. That will be our horizontal component, while vertical component, which is Vy is equal to Voy minus Gt. We already solved Voy kanina, which is negative 121.5 meter per second minus 9.8 meter per second squared multiplied by 5 seconds. 5 seconds, hindi lagi nakukuha ng camera. I'm sorry for that. That will be negative 171 meter per second. That will be our vertical component. Next, Problem number 7. A projectile is fired at initial velocity of 80 meters per second at an angle of 30 degrees above the horizontal. Find A, its position and velocity after 6 seconds, the time required to reach the maximum height, and the horizontal range. To solve for that, of course, we will first write our givens, which is V sub 0 is equal to 80 meters per second. Our theta would be 30 degrees. So letter A, we have the given 6 seconds. So to find the position, we need to find the components, vertical and horizontal exponent. So with that given, with the formulas, V sub 0 is equal to 80 meters per second multiplied by cos 30 degrees. So our V sub 0x is 69.3 meter per second. Next, we will find for the V sub 0y. V sub 0y is equal to VO multiplied by sine theta. Substitute, that would be 80 meters per second multiplied by sine 30 degrees. VOY is equal to 40 meters per second. We already have VOX, V sub 0x, and V sub 0y, so we need to find the Vx. Vx is equal to V sub 0x, so that will still be 69.3 meters per second. Next, Vy, V sub y is equal to V sub 0y minus gt. VOY is 40 meters per second minus 9.81 meter per second squared multiplied by the time, which is 6 seconds. So VY is equal to negative 18.8 meter per second. So to find for the position, we will use the formula V is equal to square root of Vx squared plus Vy squared. Substitution, we have square root of 69.3 meter per second squared plus negative 18.8 meter per second squared. So our V would be 71.8 meter per second. That will be our velocity. So to find the position, we will use theta is equal to arctan Vy over Vx. So arctan negative 18.8 meter per second squared, meter per second divided by 69.3 meter per second. That will yield theta is equal to 15.2 meters south of east. So that will be the position. Next will be the time required to reach the maximum height. So we're looking for the time. With the given we have, we can use the formula Vy is equal to V OY minus GT. Deriving the formula V 40 meter per second minus 9.81 meter per second squared T transpose by the 9.8 meter per second squared multiplied by t is equal to 40 meter per second. Divide both sides by 9.8 meter per second squared. That will be t is equal to 4.08 seconds. So that would be the time required to reach the maximum height. For letter C, we are looking for the range, horizontal range. So our formula for range is equal to Vox multiplied by the t total. The t total would be 2 multiplied the time. That will be 4.08. So 8.16 seconds the total time. So we can now proceed in solving the range with v sub 0x multiplied by the t total. That would be 69.3 meter per second multiplied by 8.16 seconds. Or our range will be 565 meters. So next,